So in today's session, we're going to be looking at the volume and curved surface area of a cone. So first of all, we need to define a cone. So we're going to do that by saying as follows. We say R, this is the radius of the base of the cone. H, that's the perpendicular height from the base to the apex, the top of the cone. And then we're also going to say we've got another value, which we're going to call L, which is the length of the sloping side that goes from the apex to the base of the cone. Now the volume and curved surface area are calculated using formulae that are going to be given to us, and they'll be given to us in any exam. And we're talking the curved surface area, so this is effectively not including the circular base of the cone. The formula I was given, so the volume is a third pi r squared h, and the curved surface area is pi r l, using the definitions that we had before. So here's an example. Calculate the volume and the curved surface area of this cone. So the process that we're going to use, we're going to start off by writing out the formula that's going to be given to us, substitute in our values. So in this case, the radius is 8 and the height is 12. Calculate the value in terms of pi, and then turn that into a number. And here I'm going to give the number to 2 decimal places, but the question will specify the degree of accuracy that you require. The curved surface area. Now to find that, we need to find the value of L. And here we've got to do a little bit more maths first of all. And to do that, we're going to use Pythagoras' theorem, because if you look, we have got a right-angled triangle inside the cone. So using our, to find the hypotenuse, we're going to add, and we find here that the length L is 4 root 13. Now the curved surface area, pi RL, there's our formula for it. Substitute our values into it. We can give our answer in terms of pi, so 32 root 13 pi, and as an answer to 2 decimal places, as we've got here. And notice that's an area, so it's centimetres squared. We could also have some variations in how the cone has been defined. So we could be given a diameter of the base, not the radius. Now if that's the case, very simply, all we do is we divide the diameter by 2 to give the radius, and then we would proceed exactly the same way as we would have done in the previous examples. Alternatively, the cone could be defined giving us the slanting height L, and then either the radius or the height. And this time, we'd require to use Pythagoras' theorem to find the missing side. And we're not finding a hypotenuse this time, and if you remember, this is going to be a short side we're finding, so our process of doing that is we know that we subtract to find a short side. So in this example here, you can see that it would be the height we need to calculate, and we were given the hypotenuse and the radius. So following through with this example, if you look, to find the height, we'd use Pythagoras' theorem, and remembering that the side we want to find would be the one we start with. That's one on its own, the height. So h is the height in this case, not the hypotenuse. So 8 squared equals 12 squared minus 6 squared, because we're finding a short side, and we can get an exact answer for what h is going to be. Now, as exactly as before, we substitute it into our formulae, just like before. We give our answer in terms of pi, and then we can give our answer to whatever degree of accuracy we've been asked for in the question. To find the curved surface area, obviously it's a little bit easier now because in this case we actually are given all the information we need. It's a case of substituting straight into our formula, work out the answer in terms of pi, and then to our given degree of accuracy once more.